Good afternoon.
Hi, everyone. Hello. Welcome to MIT's 100K launch, our finale event. I'm one of the managing directors. I'm Ezgi, and I'm with Jimmy and Gratz, who are the co-managing directors this year. In March, over 60 teams applied to the 100K launch competition. After a long judging round by 46 different expert judges, 20 of these teams made it to the semifinals. They received expert mentorship, and just a short week and a half ago, we were at IHQ picking our finalists that you'll be watching tonight. Tonight, they will present their pitches and answer questions from a panel of distinguished judges in the hopes of competing for the grand prize of $100,000. The runner-ups, second and third place, will receive $5,000 each, and there will also be an Audience Choice Award for which you will be voting tonight, and the Audience Choice takes home $10,000.
Okay. Before we jump into today's event, we want to take the time to thank those who made this event possible. We want to give a big thank you to our sponsors for this season. We're incredibly grateful for their support, making these rewards possible. The funding they provided enables us to have this competition today and continue with the 100K throughout these years, turning it from the original 10K, which then became the 50K, and today is the 100K. In addition to their support, our sponsors serve as mentors and guides to our teams and for our organizing committee members. To our platinum sponsor, Akamai. To our gold sponsors, Goodwin Morgan Lewis and Wolf Greenfield. Thank you for everything you do to make the 100K a success. We also want to thank you, everyone on the MIT 100K organizing committee. Our team members invested countless hours to ensure that the 100K is a success. And without them, none of this would be possible. We also want to recognize our video and audio production teams at MIT, the Sloan Student Life Office that assisted us organizing this event, and of course, the CAC, which is hosting us today here at the Kresge Auditorium. Thank you.
And finally, to the 300+ judges and mentors we've had this year, thank you for offering your domain expertise, mentorship, and most of all, your time, without which the competition and our finalists would not be where we are today. We are truly grateful to have such a dedicated and selfless group of supporters among the scientific, entrepreneurship, and venture capital community. Thank you for your commitment. And now, without further ado, I'm going to introduce the judges. First, we have Lily Lyman, who is a general partner at _ Venture Capital, where she has been a driving force, investing in the digitization of various industries with an emphasis on future of work, vertical SaaS, customer experience, and commerce. Prior to _ Lily was an operator developing product strategy for core products at Facebook, Instagram, WhatsApp, and Messenger. Lily holds an undergraduate degree in social studies from Harvard and an MBA from Stanford. Next, we have Dr. John Bloom, who is the CEO of Podometrics, a virtual care management company dedicated to preventing diabetic amputations. His startup raised a Series C round this year, accelerating us ever closer towards a world where diabetic patients can lead independent and fulfilling lives. Dr. Bloom is an alumni of the 100K competition, winning Pitch, Accelerate, and Launch. He holds an MD from the University of Pittsburgh and did his residency at Harvard Medical. Welcome back, Dr. Bloom. And next, we have Habib Haddad, who is the founder and managing partner of E14 Fund, the MIT-affiliated venture capital fund. It is hardly an exaggeration to say that many of the entrepreneurs from the MIT community in the last decade have been helped and advised by Habib in one way or another. E14 Fund has been the earliest investor of some of the most prolific founders here on campus, while at the same time donating a portion of its profits back to MIT. Prior to E14, Habib was a serial entrepreneur, founding Yamli and Wamda. He holds a bachelor's at the American University in Beirut and a master's in electrical engineering at USC. Next, we have Jonathan Ng, who is the CEO of Iterative Scopes, an MIT spin-out pioneering AI-based precision medicine in gastroenterology and also one of the greatest success stories from the MIT community. Just this year, they raised a $150 million Series B co-led by Insight Partners and Clear Lake to accelerate their mission in narrowing disparities in patient outcomes. Jonathan holds an MBBS from the National University of Singapore, an MPA from Harvard Kennedy School, and an MBA here at MIT. And next, we have Anna Palmer, who is a general partner at Flybridge and a leading investor in Commerce 3.0, marketplaces, mobile, consumer, and e-commerce. Prior to joining Flybridge, Anna co-founded X Factor Ventures, a seed fund focused on backing female founders and gender-diverse teams. Anna has a wealth of operational experience, having served as chairman of Doe, the premium marketplace for women-owned products, the CEO of Fashion Project, an industry leader in online designer clothing donation. Anna holds a bachelor's from Eureka College and a JD from Harvard Law School. And now, lastly, but definitely not the least, John Hawthorne is the founder and managing director of Two Lanterns Venture Capital Partners, focusing on US and Israeli software startups with the potential to create massive impact. Prior to launching Two Lanterns in 2020, John was the founder and 10-year-long CEO of Mass Challenge, which has now become a household name for any East Coast entrepreneur and commonly dubbed the most startup-friendly accelerator here on campus. John, here on the planet actually, my bad. John earned his MBA from the MIT Sloan School of Management and was also the grand prize winner of the 2007 100K competition. Welcome back, John. Let's give it up for the amazing judges we have with us today.
To all of our competitors tonight, we wish you all the best. It's been an extremely exciting journey tonight, and we cannot wait to see these ventures blossom. Let's give a round of applause to our competitors tonight. As you can see, our first pitch of the day comes from an MIT startup, Astrahl, which develops high-resolution X-ray imaging systems by integrating nanotechnologies with scintillators, expanding access to X-rays for millions of patients. Thank you.
This way. This way. No. This way. Give this switcher.
Hello, everyone. My name is Charles, and I just finished my PhD from MIT in electrical engineering. CT scanners play an essential role in healthcare. As you may already know, CT scanners work by detecting X-rays going through the patient's body and reconstructing them into slices. Despite 50 years of technological improvement, CT scanners still exhibit severe physical limitations and safety concerns. On many scans, you will see artifacts like those, which results in an incalculable number of misdiagnoses, but it also means that the patient was exposed to an unnecessary amount of radiation. In cardiac radiology alone, 50% of patients might get such inconclusive CT scans because of artifacts. Overall, there are 4 million scans per year that have to be repeated because of similar reasons, leading to a $12 billion loss in the US per year for the healthcare system. And all of those artifacts arise because of limitations in the detector technology. So at Astrahl, we build CT scanners that take high-fidelity X-ray images using our own detection technology that we developed at MIT Labs. And the image you see here was taken with one of our detectors, and the bright square corresponds to an area we patterned with nanostructures in order to enhance its efficiency. Our core innovation is an enhanced X-ray detector, which will lead to revolutionary improvements in safety, accuracy, and expanding diagnostic capability, enabling potentially very early-stage cancer detection, scanning vulnerable populations, but also preventing many invasive procedures per year. Most of X-ray detection works with scintillators. They are indirect detectors that convert X-rays into visible light. It is a very cheap and easy to integrate technology, but it comes with severe physical limitations in terms of the resolution and efficiency. It makes grayscale images because the detectors are insensitive to the color of X-rays, which in technical terms is their energy. Very recently, however, a competitive technology was FDA approved by Siemens, solving most of those challenges, but at a much higher price, and it is also much harder to retrofit in scanners and much harder to work with for radiologists. In less than a year, however, it conquered 20% of the CT market value, showing the huge excitement around it. At Astrahl, we make detectors that rely on the first type of technology, integrated with nanostructures in a way that we keep the cost low, the integration easy, and we bring important improvements in resolution and efficiency, even potentially beyond the second type of detectors. In particular, we can make colorful images so that we provide a lot more information for doctors to make their diagnostics. The science behind our technology was peer-reviewed and published in the top journal Science earlier this year. We have 2 patents and AI software that we wrote to further protect our innovation, and the additional information that's provided by our detectors can be leveraged by AI algorithms in order to train the algorithms more efficiently, which is great timing given the rise of AI in medical imaging. We have retrofitted our detectors into an existing industrial CT scanner showing 10x improvement. We have existing champions and partners at top radiology research centers in the US and at scanner manufacturer companies. We believe that this early traction might just be the tip of the iceberg, given the huge excitement in the radiology community that this technology might be transformative for much of modern medicine. So let me tell you our plan to conquer the $7 billion market. So first, we will sell our refurbished CT scanners with our detectors in there to tech-savvy radiology research centers in the US. The great thing is that it does not require FDA approval and will allow us to make clinical tests to then get FDA approval. From there, we can expand to imaging centers and hospitals, selling a full CT scanner as an OEM company. And beyond the CT market, there are many opportunities for Astrahl to innovate in industrial and medical applications. So today we're looking for a seed investment in order to expand our engineering team and bring our first product to market in 2 years. From there, we will be in a good shape to look for FDA approval. We count in our teams the inventor of this technology, chief medical officers, and startup veterans. There are 5 startups that were co-founded by some members of this team, 2 acquired, and $300 million raised in deep tech companies. I would like to thank you for your attention, and I really hope that with the support of MIT 100K, we can bring to life the full potential of Astrahl, which we believe could be transformative for human health. Thank you.
Thank you. Thank you, Team Astrahl. We'll now move into 3 minutes of Q&A with our judges. Thank you.
You had said approval. Do you think it's going to be a class 3? And then if so, any sense of what kind of data you're going to need to get that approval?
So it should be a class 2 device, so we can file a 510K. Essentially, the main thing that's going to limit our time to market will be the clinical studies. And so that's why we're already in touch with some partners at radiology centers to do this as soon as possible.
Charles, thank you very much. So I love the pitch. Can I ask a couple of questions? Number one, who buys the CT scanners or the additional, who's responsible at the hospitals for buying the additional retrofits? And then secondly, who pays for the scanners? Who pays for the scans, sorry. And then how are you planning to bridge that gap?
So, your first question about the decision market unit. Essentially, there's a financial office in the hospital that decides there has to be a return on investment most of the time for those hospitals to decide acquiring those machines. There's already a return on investment on basic CT machines. And the champions at those places are radiologists, and they just say, hey, I really want this piece of hardware. This is going to change the way I do medicine. Then your second question was about who pays what?
Who pays for the scans?
Who pays for the scans? So insurance companies and hospitals will typically pay per diagnosis-related group. So typically, if you have a patient who is staying overnight, if you have to do 2 CT scanners, you will be reimbursed the same amount. So there's clearly a loss for hospitals there because the machines are lacking throughput.
Right, and how do you bridge, because I think your stated value proposition here is you're avoiding, there are 4 million scans that can be avoided every year.
Yeah.
So how do you bridge this difference in, there's a payer that cares for, that pays for the scans and that cares about avoiding these scans, and then there's the hospital that buys it but doesn't actually.
So there's a win-win situation because the hospital is also going to get a better return on investment because the machine can have a better throughput, so it can take more patients and it will be reimbursed more often. They will have more patients going through the machine. And for the insurance company, there's this waste that's eliminated from the healthcare sphere.
Okay, thank you.
Also, I would like to add that one thing is that the hospital gets reimbursed per diagnosis. So if they have a CT scan that they cannot use for diagnosis, which actually, because for some reason CT scan malfunctions, which happens in 4 million cases per year, then they don't get reimbursed for that. So they have a very strong incentive that they don't have these 5% malfunctions, which they do.
Great, thank you.
Sort of related, can you talk a little bit about the unit economics of the business model or of the pricing construct?
The economics, you said? Yeah. So essentially right now, we are going to sell refurbished CT scanners at a price which is comparable to existing CT scanners because we do not believe that there's going to be any significant premium from doing the retrofit at scale. The first few ones might have a slight premium, but this will be for collaborations at hospitals. I see we're running out of time or not.
One more question. Yeah. I love the story. Quick question for you is, I see all the path is very hardware heavy. Have you thought about what would you do that CT scans can do once you collect so much data and you can actually go faster on the software side by doing things that couldn't be done before?
Yeah, so we think of ourselves as a full stack company. Actually, we're also developing software for the image processing and for the optimization of the devices themselves. And in the long term, we will collect a lot more data and also a lot more information in the data we have. And we plan to use it and potentially find ways to commercialize it. But this is still a very early stage, so yeah.
Thank you so much.
Thank you.
This way through. Thank you. Thank you so much, Astrahl. We'd now like to welcome our next team, our team Microfluidics, who's leveraging molecular science to build an easy-to-use home diagnostic platform to detect bacterial or viral pathogens in saliva. Take it away.
Good luck. Thank you, David. Start. Is this on? Oh, no. Before I get started and tell you about our team Microfluidics, I'm going to have to address the elephant in the room. While I go through my pitch, I'm going to ask you to please don't confuse me with Elizabeth Holmes from Theranos. I don't look like her, I don't talk like her, and unlike her, my science actually works. My time is counted, so I have to go quick. So, as a mother of 4, the one thing I feared the most when my kids were younger was if one woke up with a fever and a sore throat. The only option I had to know if I can go to work the next day was to take them to the doctor for testing and diagnostics. Can anybody relate? Well, I know, because we're not alone. In fact, 125 million people are required to see a doctor for symptoms of bacterial infections when 99% of the time it's negative. That experience is invasive, often uncomfortable, and let's be honest, a complete waste of time. So our solution is an over-the-counter at-home test that is easy to use, not invasive, and will give you reliable negative results in less than 30 minutes. We've created a molecular platform that will achieve PCR quality results in the comfort of your own home and uses 3 very distinct features. The first one is the use of saliva. We all get it, easy to use. Then it's a process of DNA amplification, which essentially means I need to look for a very small amount of pathogen to find out the bacteria is there. If I don't find it, you don't have it. And finally is our detection method that is not only simple, but with high sensitivity and specificity. Imagine being able to test for any one of these when you need it. Okay, before you get any ideas, not all at once, we're doing one at a time, and we're starting with strep. In the US, there's approximately 50 million tests performed per year, when the CDC only confirms 36,000 of them being positive. You do the math, it's not very high. And like I said before, our science works. With all of the lab work we've done with our independent lab, with our independent partner lab, we can assign 97% confidence level for both positive and negative results. We've created a proprietary formulation of both primers and bacteria that actually detects the bacteria in saliva. And if you've had breakfast, coffee, orange juice, or nothing at all, our formulation will be insensitive to the variability in your mouth. Now, for some of you who understand this, unlike needing to go to the doctor with 24 hours worth of symptoms to get testing at the doctor, our novel proprietary detection approach will require a very low bacterial count. Now, like I said before, the only way to get tested today for strep or for anything else for that matter is to go see the doctor. There are some other platform technologies in the space, but our solution checks off all the boxes for home use, ease of use, accuracy, but most importantly, affordability and accessibility to everybody. We are moving into exploding US opportunity. The home diagnostic market is expecting to grow to over $10 billion in the next few years. The strep testing market is currently valued today at $2.3 billion. Now, as our first indication, we plan on capturing 30% of that market and within 5 years of FDA approval for potential revenue opportunity of $350 million. Now, COVID has accelerated the disruption in this landscape. Think about insurance companies. They encourage home diagnostics. They don't have to pay for them. Consumers like us want to have more control over our health. And we were so happy to have COVID tests available at the pharmacies, and providers have already implemented virtual platforms to assess their consumers where consumers want to be assessed. This is us with seasoned scientists and over 50 years of biotech and device design experience. And along for the ride, a great team of advisors that are inventors, investors, and founders, who all in the biotech and healthcare space that have allowed us to move this venture forward. In the past year alone, along with validating our product market fit and proving our science, we've submitted 2 utility patents, retained a regular team, and most exciting for us, we are moving into our own bench in an incubator lab right here in Newton, Mass. Our next step is to transition from R&D to engineering and product development. And with additional funding, with your help, we will further device development, optimize the science, and actually sit down with the FDA. And I'm founder and CEO of Microfluidics, and we will revolutionize home diagnostics by getting the stress out of tests.
Congratulations, RT Microfluidics. We're going to move into 3 more minutes of... They'll turn it on, yeah.
Great job. I just went through this with my son, so understand the pain point. Curious if you could just talk to unit economics and what you're expecting to be able to sell this for, and is it eventually something where insurance would reimburse?
Hello? Oh, this is working, yeah. They shut it off for a second. So our plan is to make this for under $5 a piece in order to sell it wholesale at $15 and have it in the stores between $25 and $35.
Hi, Natalia. Thanks for the presentation. I have a quick question for you. 2 questions, actually. Number 1, does this only apply for respiratory tract diseases? And secondly is, what about contaminants? How do you differentiate?
Done.
I didn't hear the first part of the question.
Does it only apply for respiratory tract?
That's a good question. I think it'll apply to any pathogen, viral or bacterial, that will result in bacteria in the saliva. I mean, that's what our initial target is. And so in that case, I mean, I don't think it's limited to respiratory diseases. In that, there are periodontal diseases, for example, that we could target, but right. Anything that is in the saliva.
Right. And then so in that case, then what do you how do you deal with contaminants? And, for example, there's a lot of flora in the skin, there's a lot of flora in the mouth.
That's a really good question, and we haven't started looking at how interferences can apply in this case. We do know that our specific probes selected for the pathogen that we're studying for strep, is selective for the Streptococcus pyogenes that is for strep, and it doesn't see other streptococci. So whether or not that holds for all, we'd have to do the test to determine that. So we're still looking at interferences.
Totally, thank you.
Will you be able to do multiplexing on that same device?
That's a really good target for us, and you saw the slide where there were multiple diseases. There's several of those that we're considering and looking at from a multiplex standpoint. There's some breakthroughs that we need to make, so there's still some obstacles to do that, but there are, there are technologies like LFA that can be applied in that case that will enable us to multiplex the technology as well.
You had said the sensitivity and specificities are around 97%. For the targets in the pipeline, what are the typical accuracies for those gold standard tests?
We for strep, I mean, we still have to do the studies with our actual device, our final device, to characterize that. We do know that our limit of detection is down between 12 and 25 bacteria, and so I think with that limit of detection will determine what the sensitivity is ultimately. And I think we need to characterize that in clinical samples, which we have not done yet. We've only looked at spiked saliva.
Thanks.
Thank you. Thank you so much, RT Microfluidics.
Thank you.
And now let's welcome our third team, Sparkle, who have developed a patent pending dye technology that can light tumors up, making them easy to remove.
Most of us have been affected by cancer, either directly or through a loved one. The key to fighting cancer is to remove it entirely. That might sound straightforward, but as a physician, it's not that easy. And actually, the way that we do things is not really fair for patients. Let me show you what I mean using breast cancer as an example. In the amount of time it took for me to go over that last slide, a new patient has since been diagnosed with breast cancer. Let's follow her journey. The first step is to undergo surgery in the operating room. Here, the surgeon removes the tumor and sends it for tumor margin analysis, which is where they stain the tissues and look at things under the microscope to make sure there's no residual cancer. But this process can take hours to days. Meanwhile, back in the operating room, the surgeon will close the patient up. The patient will then go home without knowing whether or not her tumor has been fully removed. A week later, she'll get a call from the surgeon with the results. If the margins still contain cancer, then this whole process has to happen all over again. The lack of real-time tumor margin information is why 25% of patients have positive margins the first time around. It's also why 10% of patients require 3 or more surgeries before finally getting clear margins. This is a huge problem, and we're the team to solve this problem. Our core team are experts in surgery, immunostaining, and synthetic biology. Together, the five of us have more than 25 patents, a third of which are licensed for use. This current technology comes out of the labs of Professor George Church and Professor Jim Collins. My name is David Lee. I'm a resident physician at Harvard. I want to introduce my colleague, Elena, who has, she spent her entire PhD at MIT building the same types of assays that we are here to replace. Take it away.
Thank you, David. So these images show what a tumor looks like. And as you can see, it's very difficult to distinguish the tumor margins in yellow without doing immunostaining, which is the image you see on the right. So immunostaining takes time because it has many complicated steps, so it cannot be used during surgery where time is of the essence. Our solution is the patent-pending Sparkle instant nanosensors. We have combined the accuracy of immunostaining with an instant readout through a novel mechanism. We use conditionally fluorescent molecules and we attach them to protein binders, such as nanobodies. The nanobody complex is highly specific to its target, such as the tumor protein, and when it binds, it glows, resulting in an instant signal. Our sensors do not require washes, so they can be used at the point of care. Here you see one of our sensors rapidly turning on and glowing once it finds its target. We hold patents for every single step of the process. This includes composition of matter patents for the conditionally fluorescent molecules, as well as methods for their use. We have already developed more than 10 sensors, and it takes us 3 weeks of research to develop a new one. And our sensors are instant. So that means that the assays that used to take days now take milliseconds.
Current technologies require a trade-off between speed and accuracy. We have bypassed this problem entirely by reinventing the mechanism of how immunostaining can be performed. This is why Sparkle is a platform technology that has numerous indications for both research and diagnostics. Our beachhead market will be breast cancer surgery in the United States. Capturing 10% of this market will yield an annual revenue of $11 million just from one disease. We plan to replicate this across other diseases in our pipeline, which is why we're looking at a total addressable global market of $50 billion. To date, we have engineered more than 10 sensors for 5 different diseases. In addition, we have conducted more than 100 interviews with key stakeholders, more than 90% of whom said they would purchase this technology when it's out on the market. We hope to utilize $100,000 to further refine the performance of our sensors in patient tissue samples acquired from regional biobanks before getting FDA approval. So let's go back to our patient before we end. We think this loop of uncertainty is not fair for any patient to go through. With our Sparkle technology, we can have confirmation of margin clearance during the surgery so that the patient can go home knowing that her cancer has been fully removed. With that, we are Sparkle Biosciences. I hope you'll join us in lighting up cancer, one tumor at a time.
Thank you, Sparkle.
Yeah, I know.
I must say that presentation sparkled. Now on to the 3 minutes of judging. Thank you.
In my former life, so warning, it's like a long time ago, in anesthesia, we would often pause cases. It would be sent to path, and then we'd wait for it the data to come back to decide, do we keep taking out more or hold there? How common is that? Is there problems with that type of process?
So that's a really good question. So I guess just to clarify, your question is there an issue with pausing the surgery just to wait for path to get back with results?
Well, certainly you don't want to leave the patient open, but there is a process mid-surgery where we can evaluate if the margins are clear.
Yeah. So currently the ways of doing that, I mean, there's a few approaches. The sensitivity of all of those approaches are imperfect. So for instance, there's something like touch prep, which has a sensitivity of 70%. You can get frozen sections just for regular, H&E staining. But with H&E staining, you don't want to rely on that for something like malignancy. So, the perfect approach would be to utilize immunostaining, which has near perfect sensitivity and specificity, right? The problem is the way that it's currently done, it takes too long. But with this, we can basically still go through the same routine as a frozen section. We can create some kind of stat protocol for them to bring it down to path. They can section it there, and then they just apply this stain, and it will be instantaneous. That's the goal of it.
I have a question around your business model. I think I saw that you were planning to charge $200 to $300 per stain. Can I ask who's paying for this? Who do you expect to pay for this?
That's a great question. First of all, the number of $200 to $300 per stain is one that we thought a lot about. It's there's various ways of looking at it. We can do cost-based pricing or value-based pricing. And in this case, we decided to go with the latter because our whole premise is that we're going to be saving the patient and the healthcare system unnecessary surgery. So in terms of who's going to pay for it, I would say in an ideal world, of course, insurance would ultimately pay for this. The reason for that is because, as you know, with many other surgeries, within a 90-day global period, the hospital's not going to get reimbursed for a second surgery of the same procedure, right? Which is exactly what this is. A few weeks later, the patient would need a re-excision in which the hospital isn't paid for that. So honestly, hospitals and insurance companies are both incentivized to pay for this stain, and because of that, we can actually upcharge, but at the current moment, we're just looking into charging it slightly higher than what is the Medicare reimbursement.
Right.
Can you talk a little bit about how you'll bring this to market and what the go-to-market strategy looks like?
Yeah. So, currently, the plan is really to think about how we can bring the greatest impact at the fastest time. So we want to enter the OR, like we want to enter the operating room. That's our go-to-market strategy. Like I said, this is a platform technology. It can be used for, like we can license out the sensors for research use as well. But really, we want to focus on high impact, which is we're going to be focusing specifically on academic medical centers, of course, regionally first. Getting into the ORs, and then after that, we can also simultaneously, collect revenue from research use. If you guys want to add on to that. Okay.
Okay.
All right. Awesome.
Thank you.
Thank you, judges. Thank you, Sparkle. And now let's welcome Encreto Therapeutics. This team is tackling obesity in a whole new way. Instead of hormone mimetics, they're discovering medications that help the body produce more cells that secrete appetite-controlling hormones. This is something I really need.
This way? Okay. Hi, everyone. My name is Genevieve Rogers. I previously worked in healthcare, management consulting, and I successfully founded a nonprofit.
And I'm Daniel Zeev, MD, PhD. I'm a pediatric endocrinologist and researcher at Boston Children's Hospital.
Today, we are pitching Encreto Therapeutics, a drug discovery platform specializing on the endocrine system. Specifically, we are targeting oral medications for patients with obesity. The Encreto team is made up of myself, Daniel, and our third co-founder over there, David Bro, who's also an endocrinologist at Boston Children's. Now, over the past 20 years, the number of patients who have entered Daniel's and David's offices for treatment for obesity has risen dramatically, a trend reflected across the country and around the world. In fact, we are not that far away from seeing the disease impact 1 in every 2 Americans. This translates into significant downstream health impacts and massive patient expense. Now, I have to give you a short biology lesson, but this is MIT, so I know that you can handle it. Your appetite is largely regulated by hormones that tell you when you're hungry or when you're full. These hormones are secreted throughout the intestine through cells that are called enteroendocrine cells, and that is your vocabulary word for the day, enteroendocrine cell. And what you can see in the graphs here is that patients with obesity produce significantly fewer of these hormone-producing cells than patients without obesity. That means they have to eat more in order to feel satiated, which is a big reason why treating the disease through diet and exercise alone is so incredibly challenging. Now, medications in the market today address this challenge by giving hormones directly to a patient. Unfortunately, this can come with some pretty serious side effects, and as many as 30% of patients experience side effects like vomiting, GI pain, and nausea. What is more, these medications are super expensive and require weekly, if not daily, injections. This is why Encreto is going after the root cause. Instead of giving hormones to a patient, we are after medications that enables a patient to produce more of the cells that secrete appetite-controlling hormones. By helping patients manage their disease through a more natural mechanism, we can help them achieve satiety without those side effects.
Now, Encreto's innovation is a discovery that allows us to screen hundreds of thousands of compounds to see which ones can produce enteroendocrine cells. To perform this screen, we use intestinal stem cells, which are found throughout the gut. We get these stem cells from donated human biopsies and then grow them as groups of cells called organoids. We take those organoids, we put them into a screening plate, and then we add the compounds on top of those to see which ones can make hormone-producing cells. Now, why do we think we can do this? Because we've already done it. So these are control organoids, and these are organoids exposed to compound A, which we discovered can make more enteroendocrine cells. Now, unfortunately, compound A is not suitable for human use for reasons that we don't have time to get into right now. However, this is the whole point of the screen, to identify novel compounds that have the same effect, but that can be used in humans.
Encreto's ultimate vision is a treatment care plan that enables patients to manage their disease by taking one pill once a day, priced at $1 a day. The unmet need in obesity remains massive, and if Encreto were to serve just 1/3 of patients at our target price, it would be an annual revenue of $15 billion a year. Encreto has 3 competitive advantages that, taken together, make us one of the only companies in the world capable of doing this kind of work. The first is access to diverse organoid lines through partnerships with Boston area hospitals. The second is our proprietary technology, including a patent on our screening process, as well as the ability to patent hits from our screen. And third is our leading expertise, with more than 25 years combined treating patients with obesity. So far, we've completed our proof of concept and are incrementally scaling our screening capacity. We're seeking funding today for our end-of-year milestones, which will enable us to increase our screening capacity tenfold. The last thing I'll say before I close is the future potential for Encreto. I know we talked about obesity today, but enteroendocrine cell production is dysregulated in a variety of diseases, and we can use Encreto's discovery to search for therapies throughout them. I hope that you will join Encreto's mission of improving treatment options for patients with obesity by supporting us in the 100K competition. Thank you.
Congrats, Encreto. I'll put in a good word with the judges if you make me your first customer, please. You've got 3 minutes. Thank you.
What percentage of patients with obesity have insufficient enteroendocrine cells?
That is a wonderful question. So I'm going to go at it from a different angle because I can't 100% answer that, but I know very, very small percentage of patients with obesity have a genetic, like a solely monogenetic cause. So that's like one gene is mutated and they're very obese. This method would not work for that. However, I firmly believe that the rest of the people that have obesity or who are overweight that is from like a mixture of genetics and environment have decreased enteroendocrine cells. And that's why the current drugs on the market today, those GLP-1 receptor agonists or the mimetics, work so well because they're making fewer of those hormones.
Mm-hmm. And we included 1 study in this pitch, but we have 3 or 4, 5 we've looked at that all found the same.
How much of the discovery part can you do in software? Can you, and it doesn't seem like you do that today, but could you?
That's an amazing question that I haven't really thought of. But so right now we're not targeting a specific protein. We're just basically saying, so the differentiation of a stem cell into an enteroendocrine cell is not well understood. And we've made small inroads with the compound A, B, and C, that we've discovered and published in our recent paper. But that's the kind of beauty of this screen is that we're going much more like global and not looking at one specific protein. But I think
But you think over time you might
over time, if we find a hit and the hit kind of identifies a pathway, then we could use that route to find more.
Yeah,
Absolutely.
The alternative approach today would mainly be mouse studies, which is just too cost prohibitive to do the kind of screening we're talking about at scale. So by doing this in human cells, we also expect higher translatability when we do go to human trials.
Just have a question kind of on status and business model. So it sounds like you've created a platform for screening lots of compounds. You've identified one that theoretically could work but wouldn't actually work in humans. My understanding is that you get paid for the actual compound that you produce, not for the use of the platform for screening. So first of all, is that correct, right?
Yes.
But then secondly, this platform could also be used to screen for other diseases and et cetera. So why did you choose this as a starting point, obesity, in this particular disease? And then what other diseases look promising, and how long until you start screening for those?
So we start with obesity because those hormones that are produced are just so closely linked to appetite. And plus Dr. Bro and I have worked, that's part of our work is to treat kids with obesity, so we're very close to that. The other diseases, which we had on the slide, were type 1 and type 2 diabetes, which I may or may not, I don't think we have time to get into today, especially type 1 diabetes, but there is suggestions in the literature that enteroendocrine cells can make insulin when pushed. And then these other intestinal diseases all have dysregulation in hormone production. So, it may be instead of looking for increased hormone, we try to diminish or suppress the amount of hormones produced. But those are things that we're starting to think about, but we haven't really gotten
Start
into
with what you know, and obesity is, Daniel and David are being humble. They're incredibly talented in that space.
Great.
Thank you, Ezgi.
Thanks.
Thank you.
Thank you so much.
Thank you so much, Encreto. And we're now going to turn to our 5th finalist, Iridence. It's a company inspired by a bird feather. They've developed and patented a biomaterial named Erica, made from the same material found on our skin. Take it away, Erica.
Hey everyone, Iridence is a biomaterials solution platform, and the name Iridence is inspired by bird iridescent because we are making shiny biomaterials for the cosmetic and beauty industry. There is an ugly truth about the cosmetic industry right now, which is mica mining. So what is mica? Mica is a mineral that makes your cosmetic product look shiny and glimmering. But unfortunately, it is environmentally damaging, and it is fueling child labor in places like India and Madagascar. Its alternative right now, synthetic mica, it is still a mineral, as you can see from the chemical formula. So it does not solve the root issue, which is mining. Thankfully, in the past few years, I've been working with Erica, and Erica has real potential to replace mica in the supply chain because of these three reasons. First, it is cheap because it is made from the same material as our skin, and it is clean because it is entirely lab-grown from protein powder. It is also colorful because it uses the same iridescent physics in bird feather. So how Erica is made? It is made using our patented computer-driven platform that can automate biomaterials design and production. And by the way, this pipeline is material agnostic, so we can use it to reproduce properties in other mined materials. It can be plastic, it can be other mineral, it can be metal, or even chemical, and so on. If you look at the chart, Erica has real competitive advantage over natural and synthetic mica because it is the only alternative out there that is both entirely lab-grown and mineral-free. So right now, the production cost of Erica is still a little bit expensive. It costs about $10,000 per kilogram. That's why we need to use bioreactor to scale up the production to reduce the production cost to below $1,000 per kilogram in order to be competitive enough to challenge synthetic and natural mica. So the global mica market is about $1 billion. If we're able to capture just 10% of it, it's already a $100 million market size. So right now, we are in the fundraising and incorporation phase. In the next few years, we need to forge strong partnership with leading beauty brands such as Sephora and supply Erica to them. And in terms of the product, we need to start building manufacturing facilities such as bioreactor to scale up Erica production. And in the near future, we will even expand beyond Erica to increase our total addressable market. Because the global mining market is about $2 trillion. If we're able to use biomaterials to replace just 1% of it, it's already in the tens of billions of dollars. So our vision is really to become the app store for biomaterials design and production, to use biomaterials to replace mined materials. And my name is Dee. I'm the founder of Iridence. I'm currently a fifth-year PhD candidate at the Department of Biological Engineering, and my core inventor is Professor Chris White, a pioneer and leader in the field of synthetic biology. And with that, let's join Iridence's journey to build a greener and more sustainable future. Thank you.
Thank you, Iridence. I don't have to say it again. 3 minutes of questions. Thank you.
Can you talk a little bit more about the sales cycles into those beauty brands and what you're expecting as far as, how hard is that to get them to actually change those compounds inside their cosmetics?
Yeah, so right now they are using ethically sourced mica, and as I mentioned, it is not really ethically sourced. It is still mica, a mineral. So all we need to do is really to make my biomaterial like in large scale and supply those material to these beauty companies. They are really shouting for an alternative right now, and there isn't any alternative that is mineral-free, but ours is made from entirely protein powder. So it's tyrosine powder. You can buy it at CVS right now, but the CVS one, the purity is not that good. So that's why we need to really scale up, have the manufacturing facility and all those to do all this.
Great, thank you.
It appears to me that one of the potential lowering cost factors you have is on the bioreactor side and the manufacturing side. But I haven't heard you talk about any work on innovating in that space, whether it's monitoring or whether it's new types of bioreactors? Is that something, I mean, there's plenty of other companies working in that space too. Do you think you're going to partner with the likes of Culture Bioscience and others, or develop that in-house?
Yep. Yeah, that's a really good question. So right now, the two expensive thing is the enzyme and the peptide. The peptide is expensive because it is peptide synthesized right now. So in order to lower down these two, first we can use bacteria to produce enzyme in bulk. So we can partner, for example, with Ginkgo Biowork or some lab to produce this enzyme in mass scale. And the second one is really the peptide. And again, we can use E. coli and bacteria to produce those. And right now, because I'm doing in the lab, not in the bacteria, that's why it is expensive. So next step is really to scale into bacteria, use a bioreactor, produce everything in mass, and then hopefully we can have less than $1,000 per kilogram.
Do you think there's a world where you go direct to consumer?
Yeah, that's a good question. So because right now, like the beauty companies, they are really shouting for a product like this. So I think it just makes sense to be a supplier, to supply Eureka to them directly. And they will like incorporate into their cosmetic product and sell to a consumer. So I don't think it's good to like challenge the beauty companies and make our cosmetic product and supply to customer. I think it's better to forge partnership with them, just supply to them. Yeah.
In the last 10 seconds, just why did you start with mica? Since it's a platform, you could also go after other materials.
Yeah, because there's real demand for it right now. Like they want it right now. We can do for like plastic and other chemicals, but those there are alternative for those. But mica is really the one that we can have a market and demand like right now.
Great, thank you.
Thank you.
Yeah, thanks.
Thank you. Thank you so much, Iridence. I'm really excited to welcome our sixth team, Nona Desalination. Their portable desalination device produces enough water to support a group of 10 people at a third of the weight, half of the cost, and 1/10 the amperage of the best reverse osmosis competitor on the market. Take it away, Nona.
Hi, I'm Bruce. I'm representing Team Nona, and our mission is to make portable desalination sustainable and easy. This is a picture of a Houston suburb after Hurricane Harvey in 2017. Now you may look at this picture and think, water scarcity? Those people have too much water. And you're right, but the flood water you see is mixed with salt water from the Gulf, sewage from water treatment plants that were flooded, chemicals from the local refinery, and even E. coli from cattle ranches nearby. An estimated 500,000 people were left without access to clean drinking water after this disaster. And in some cases, it lasted for up to 2 months. People were advised not to drink their tap water. And we normally think of water scarcity as a problem for the developing world. But in reality, it's a growing problem even for the developed world. If you think about tropical storms, drought, infrastructure crises that crop up, like in Flint. So I want you to think and ask yourself, what would you do to be prepared to not run out of water in a crisis like this? The answer for most people is hoard bottled water. But bottled water has some problems. Number one, it takes a lot of space. Number two, it runs out, so you need a lot of it. A family of 4 to last 2 months would need an entire pallet of bottled water. And that's expensive. That $500 pallet of water in your garage needs to be replaced every year because bottled water expires. Most people don't know that. There is an ideal solution called portable desalination. These devices, which you see on the right, allow a person to take seawater, floodwater, lake water, anything, and turn it into clean drinking water. And that's amazing. Why haven't you heard of this? Because these devices that are on the market today have some big problems. Number one, they're difficult to use. Number two, they're expensive. You're going to pay at least $4,000 for a device like this. Number three, they're not all that portable. The smallest one that boasts how portable they are is like 75 pounds and quite bulky. This is to scale. And fourth, it requires a lot of electricity. So there is a storm, your power's out, what do? You need a generator. Our solution does what the competition does. It turns seawater into drinking water, but it does so completely off-grid, just using a small solar panel. It's compact. Think 1 case of bottled water. That's the size and weight. It's economical. We can have a 40% margin, at just 1/3 the cost of the best competitors. And it's easy to use, single button operation. That's it. So why can we achieve these specs and our competition can't? Well, it's because they use a centriole technology called reverse osmosis, where essentially water is shoved through a membrane at upwards of 800 psi, and that takes super high pressure. If you have a high pressure pump, you need a lot of electricity. If you've ever heard that desalination is expensive or energy intensive, it is, and this is why. Our solution uses technology that was developed here at MIT in the Research Laboratory of Electronics. We never push water through a membrane. We pass it through a channel and suck out the salt and the bacteria using an electrical current. Because we can do all this at super low pressure, we don't need a high pressure pump. And because of that, we don't need much electricity at all. Our device runs on less power than a cell phone charger. We plan to sell our first units to sailors who are super enthusiastic about this product, probably because they're the primary users of current devices on the market. After we've tested the device with those extreme users, we want to go to emergency preparedness in the US, which we estimate to be a $5 billion opportunity. From there, we take it on the road, and we address global disaster relief and global water scarcity. And beyond that, we think this technology can be applied to other uses aside from portable desalination, including hydrogen production and oil-water separations. You may be thinking at this point, this sounds fantastic, but how many years and how many millions until it gets out of the lab? Well, I'm happy to report that we have a prototype that works in the real world. It just needs to be scaled up a little bit to be exactly what our customers want, but it does work. We have three patents. We've been funded by the US Army. We've been funded by JWAFs. We've talked to lots of super enthusiastic customers and beta testers. We've demonstrated that for just $10 spent in digital marketing, we can produce one pre-order. With our 100K winnings, we plan to primarily put beta prototypes in the hands of customers. We want to verify that product market fit, and we want to make sure our device can stand up to the demands of the real world, day in and day out. We have an awesome team. It includes the inventors of the device, Dr. Jung Yoon, who you'll meet, Dr. Jae Han from the Research Laboratory of Electronics. Myself, I bring finance and strategy by way of Rivian, where we brought the world's first electric pickup truck to market last year, and our talented industrial designer, Kevin Teng. Together, we're Nona, and we are making portable desalination sustainable and easy. Thank you.
Now, Bruce, people call me salty all the time. Will it work on me? Can I put this in my home?
We'll try to help you, Ezgi. Yeah.
Thank you. All right, now we've got 3 minutes of questions.
So I just have a quick question about, does this work on, what type of contaminants does this work on and what does it not work on? Does it work on all different and genuinely produce clean water? Or what about sewage or more complex chemicals, arsenic, or is it just on salts and ionized contaminants?
Yeah, fortunately, all the suspended particles such as bacteria and virus have the negative charge. If it has the positive charge, it already aerated and got down to the ground. And it is the electrical driven removal process, so we can remove all the suspended particle like a pathogen. Yeah.
And including biological contaminants?
Yeah, of course.
Awesome job. Why start with sailors? Why, I mean, if it works as you're saying it does, which I believe, but why start with sailors? Why not think of a different, bigger market? It seems like a non-transferable market when you think about sailors and then going to consumers or going to different spots.
Yeah, that's a great question. It's one we've wrestled with a lot because there's not a lot of sailors. It's really not a big market. We do think there is some strategic transferability to our next market. Because in emergency preparedness, you want to make sure it's tough and it really works a lot. And someone who wants the device for emergency preparedness, that's not your ideal tester. Like, they're going to put it in the basement and hopefully never use it. They're going to put it in the garage and use it on a rainy day. The sailor is using it all the time. So it's important to us to show that we can win there, and that'll give us credibility. Also, we're also talking to the military. We have some funding from them for a similar reason, credibility.
I think similarly on that note, does the technology scale up? Could you do this at mass scale for like a city or a town? Or does it work only in smaller?
Yeah, if you remember our technology, it is the stacking of the water flow channel and the ion exchange membrane. So in order to scale up, we just need to scale up the staking more ion exchange membrane water spacer. So it is really easy to scale up.
I have a question around the current incumbents. You stated there's like 3 or 4 other incumbents right now in the market. How much better than the current incumbents do you think you need to be in order to like unseat them? Because I suspect, for example, FEMA will have an inventory already of incumbents, right, for emergency preparedness. So how are you going to persuade them to replace the existing machines?
Yeah, for FEMA, FEMA isn't using many of the incumbents right now. When you think about portable devices, they're shipping a lot of bottled water. But it's different for every use case. So some customers care a lot about reliability, like that's what sailors care about, and they also care about cost. For FEMA specifically, you got to compare it to bottled water. And if you think about a pallet of water, you're paying like $600, and it expires every year. So what's the annual cost on that? Versus our device, which will cost like 1,500 years and lasts for 10. So the annualized cost to someone like FEMA, who's dealing in bottled water right now, that just sits and is ready for an emergency, we think we'll have a big cost advantage. I don't know where that line is. We probably have to be, quite a bit better, and I think we are.
Thank you.
Thanks, Bruce.
Thanks.
Thanks, Nona. Next up, we have Mantel. Mantel is developing the first and only liquid phase carbon capture material that operates at high temperatures. This means that they have the potential to unlock gigaton scale carbon removal. Thank you.
At Mantel, we're developing a new technology to capture CO2. We could reduce the cost of carbon capture and storage by more than 40%, unlocking the potential of this solution to mitigate the worst consequences of climate change. We need to be capturing billions of tons of CO2 to meet our climate goals, and doing so will soon be worth trillions of dollars annually. The problem is simple. The problem is that existing carbon capture technologies are prohibitively expensive, limiting their deployment. We need radically new solutions. And that's exactly what we've developed. The first high-temperature, liquid phase material for carbon capture. Now, you should have 2 questions. Why on earth would you want to operate a carbon capture system at 600 degrees Celsius? And what can you do with liquids that you can't do with solids? Let's start with the temperature piece. Most carbon capture technologies operate at low temperatures. These systems are almost entirely defined by the energy required to drive the desorption and regenerate a pure stream of CO2 for storage or utilization. But a large amount of energy is generated on capture in the absorber. At low temperatures, though, this is low-quality heat that gets wasted from the system, resulting in an energy penalty of between 2.5 to 4.5 gigajoules per ton of CO2. High-temperature carbon capture means flipping those last 2 unit operations. With the capture done upstream of the heat recovery, all of the energy generated on capture is passed through the heat recovery system as high-quality heat that can be utilized, reducing that energy penalty to as low as 1.5 gigajoules per ton of CO2. Now, we're not the first to try and exploit the thermodynamic advantage of high-temperature carbon capture. People have tried to do this using solid-phase materials. The problem with solids is they degrade and sinter. They aggregate and lose their surface area capacity. Here you see calcium oxide losing 70% of its capacity within 10 cycles. We have solved this problem. Our liquid phase materials are immune to this degradation path. Here you see 100 cycles of capture and release, which we extend to 1,000 cycles. That's 40 days of continuous operation with a less than 0.1% change in performance over that time. So by combining high-temperature operation with liquid phase materials, we can bring down the cost of carbon capture and storage by more than 40% compared to the state-of-the-art technology. Now, we have a choice about where we apply this technology, and we're building a platform of solutions. We can address CO2 emissions in hard-to-abate sectors like cement and steel, in hard-to-abate geographies like Asia, where coal and natural gas will remain prevalent for decades. But the application we're seeing the greatest demand for is bioenergy with carbon capture and storage, or BECCS. By combining two clean energy technologies, you can remove CO2 from the atmosphere, an application that's seeing explosive demand right now. To meet this demand, Mantel will work with partners to build carbon capture projects, collecting a technology licensing fee and taking an equity stake in each project. We've met with over 50 potential partners and customers so far, and they're all extremely excited about this solution, but they have one question: does it really work? So where are we with the tech? We've proven this at the bench scale, and we have conceptual designs for a full-scale system. We're raising $5 million to build a flow loop, a refrigerator-sized system, while carrying out detailed design studies for a full-scale system. We'll build a demonstration plant that's commercial in scope, while filling out a pipeline of projects ready to be implemented. We'll then scale commercially with the goal of ultimately licensing our technology and being the lowest cost carbon capture solution available. I'm Cameron. I'm a dual PhD MBA student here at MIT. I've spent the past 5 years developing this technology with Professor Alan Hatton and Professor Takuya Harada. I have two amazing co-founders. Danielle has over 5 years of experience in power plant operations, and Sean has almost a decade of experience working with molten salts and high-temperature systems. Mantel is developing the material solution to carbon capture, molten borates. We could reduce costs by more than 40%, capture billions of tons of CO2, and help the world meet its climate goals while tapping into a $1 trillion opportunity. Thank you.
Thank you, Mantel. And now we have 3 minutes for questions from the judges.
Thank you. You mentioned a business model combination of a licensing fee and an equity model. Can you talk a little bit more about the equity piece of it?
Yeah, so one of the challenges we have in this space is you're in a very risk-averse space. So these utilities are not incentivized to take risk. So we have to assume a lot of that risk to de-risk the technology to the point where it can be accepted in the market. So the early plants we'll build, we will raise the capital to implement those projects and take an appropriate equity stake in those projects. And as we de-risk the tech, you can access project finance and you can reduce your equity stakes.
Okay, that's going to be my second question in terms of how you think of the type of capital you'll need to deploy that business model.
Yeah, so at the beginning, we raise the funding and we implement the risky projects. As the project gets de-risked, you get access to project finance. You start with companies that take more risk, but they're still essentially bankers. And then you ultimately access the kind of mainstream project finance, which is how big infrastructure is done at scale.
In terms of deployment, have you thought of plugging into industries where there's excess heat and loss heat versus licensing?
Sorry?
Versus one of the go-to-market strategies, which is just licensing it out. But have you thought of you building it out and plugging in into excess heat?
So our goal is to license the technology. Mm-hmm. The problem we have is you have to be able to prove that the technology works first, and that's really the path we have to get to. But you're right, you can apply this technology to a large number of applications where there is excess heat. And all of those applications I mentioned are sources of high temperature heat, so cement, steel, coal, natural gas. Am I answering your question, Habib? Yeah, thanks.
So it looked like around 2030 sort of being able to get up to scale and stuff. So it's kind of a longish time frame. Talk to us a little bit about how much money you need to raise, you think, to get started, and kind of what are the biggest risks and obstacles between you and market adoption?
Yeah, so this is a lot of capital. It's a long time frame. The steps we're taking to reduce that are parallel pathing a lot of the tech development with the project development. Project development is very time consuming in this space. You start that when you start the tech development and run them in parallel. So that's how we're getting there in the late 2020s. We're raising $5 million now to do that prototype system at the sort of refrigerator scale. We're then going to raise between 20 and 30 million to build that demonstration plant. A lot of that depends on how much access we can get to non-dilutive funding like ARPA and things like that. And then you're looking at around $100 million raise to implement a pipeline of projects, at which point the technology will be de-risked sufficiently that you have access to that project finance and you can just license the technology out.
Did you say that the proprietary part was the liquid part, not the high heat part?
Not the...
Was the proprietary part specifically the liquid phase part, or is it both liquid and the high heat?
It's the molten borate materials themselves for capturing CO2. So we have 4 patents related to those materials in that carbon capture process. You've got 10 seconds. Good? Yep. I'm over?
Over,
Thank you.
Mike.
Thank you.
Thanks, Mantel. I would like to announce that unlike Mantel, I cannot operate at high temperatures. Inclusively, which is up next, is a solution designed to help people, teams, and organizations create a more inclusive culture by starting with the basics: communication. They use conversational AI and natural language processing to detect words and phrases that contain bias and can measure the level of bias or inclusivity of the communication. Take it away, Inclusively. Woohoo!
Hi, I'm Yeti, and I'm joined here by my amazing colleagues, Joyce and Priya. Collectively, we represent more than a decade of experience building and scaling highly technical ML-based enterprise solutions to millions of customers globally. But more importantly, we understand what it feels like to be excluded, and we're here to build a world where everyone feels invited to the conversation. So we're all used to hearing, hey guys, in a meeting. But what if I said, hey gals? Should feel the same, but it doesn't. What if we said, hey everyone, instead? This is an issue that even our team struggles with, and we could all use a little bit of help to become the most inclusive versions of ourselves. And creating an inclusive culture is becoming an important issue globally. Just last year, during the height of the Great Resignation, a study done by Harvard and Duke showed that more than 65% of employees who resigned cited feeling that their managers did not create an inclusive enough environment. And this leads to real costs. Replacing a single employee can cost as much as 3 times their annual salary and can cost US businesses up to $1 trillion annually. And still, there are companies that are trying to shift resources towards these issues. Just over the last 5 years, the heads of diversity recruiting has doubled. And the trend for global spending towards DEI is trending towards $15 billion in just a few years. And yet teams are still lacking the actionable tools needed to transform their daily habits around inclusion. And this is where Inclusively steps in. Here we have Chris. He's a partner at a firm, and he's downloaded the Inclusively browser plugin to draft his email, and is already getting suggestions on how to be more gender neutral. Hi guys to hi team, chairman to chairperson. And the use cases extend beyond just gender neutrality. Here you see an example of age inclusion. And we're trying to address multiple spheres of enterprise communication, not just employee-to-employee communication, but think about customer service agents that are servicing users around the globe, or marketeers using Inclusively to craft their campaigns. We're also tackling multiple facets of toxic communication, including discrimination, microaggression, to condescension. And we're able to address these nuanced communication challenges using our deep technology stack comprising of 4 key facets. First, we have proprietary data sets that have curated over 1 million workplace emails. And second, we're using language neutrality algorithms trained using cutting-edge NLP models that take into account vector embeddings and can account for the surrounding context of words. And third, we're using in-house data labeling processes that incorporate DEI expertise. And finally, we're anonymizing our data to ensure maximum data privacy protection. I'll pass it off to Joyce.
We are at the exciting intersection of 3 growing domains: conversational AI, business coaching, and DE&I spend. When we look at the competitive landscape, many of our players, like Grammarly, are focused on fixed rules, like grammar or diction. Inclusively goes beyond clarity. We take into account nuanced, changing lexicons and flagging things like aggression or condescension. When we think about go-to-market, we currently have built out our initial prototype and are partnering with DE&I experts to build out a browser plugin. Next, we want to partner with other enterprise clients, specifically in their DE&I and recruiting spaces. And finally, we want to scale with enterprise through third-party integrations. On traction, we've conducted numerous interviews from various chief of diversity officers at Fortune 500 companies. Through these conversations, we've secured 4 pilots, 2 at MIT and 2 directly in the industry. Additionally, we've brought on board phenomenal experts in the field as our advisors, Rama in AI, Dev in product, and Reza in DE&I. At Inclusively, we provide actionable, real-time communication coaching. We want to bring everyone in. Thank you so much.
Thanks, Inclusively. 3 more minutes of questions. Thank you.
For the revenue model, is it to each enterprise, or is it per individual download to install the software?
We're thinking about freemium model. Right? Cool. Yeah, so we're thinking about freemium model where we'll open it up for individuals to try out the product through browser plugin. And then we'll have an enterprise subscription, which will be opened up for a team size of 3 to 5. For example, our competitor Grammarly has a subscription of $40 per month for a team size of 3 to 5.
A sense within the organization who you'd be selling to? Is that DEI? Is that HR?
Yeah, so we went through several discussions with the diversity officers. We're specifically going after the HR budget, going with the chief diversity officers. They have, in the last 2 years, substantially increased those budgets, and they're currently just resorting to training and workshops, having consultants come in and talk about these things, but what they're missing is actionable tool. So the budget that's used for, these trainings and workshops will be shifted towards this product.
Have you thought of how to measure success beyond text? Because text is almost like solving or band-aiding maybe a racist or a sexist comment versus really solving to the root and going beyond maybe voice or other kind of metrics that would percolate to the company and then become a sticky product.
Yep, absolutely. So one of our key metrics that we've discussed with the diversity officer is the attrition rate. We have to ultimately tie it to the bottom line. And today, attrition rate is measured for most big tech companies through monthly cadence. But it's the way they measure it is not very, I would say, objective. It's through the employee surveys, etc. And at the exit, they have an interview, and so on. So what we hope eventually is Inclusively can be used to tackle and objectively measure attrition rate. And as well as, I think, just in terms of your question around going beyond text, I strongly feel that first, language exists everywhere in the company. Job description, product documentation, the press release, the emails, the Slack, and with honing on the text itself is a pretty big market. And once we achieve that, there's obviously opportunity in the Zoom calls, on the video and the body language, but I still feel the text itself, the performance review, and this text everywhere.
I have a question around, sorry.
Go ahead.
What's your moat versus the platform owners like Gmail and Slack?
Yeah, so I think moat is something we spend a lot of time thinking about with our advisors. So there are 3 key facets. First, just comparing, Grammarly is our head-on competitor, but the data that we're using is completely proprietary. Grammarly today is trained on documents and trying to train the models for things like spelling correction. Versus we are tackling personal communication and especially extracting sentences which are toxic. And for that, we've extracted over 1 million emails from corporate discussions that we've gotten access to, and we've extracted the toxic sentence from them. Second, we have in-house data labeling process. With the help from Dr. Reza, we're able to use the theory and research on inclusion to identify some of these nuances and collect labels on that. And lastly, I feel that the market for workplace productivity tools is growing. We first had Microsoft Docs, our beloved Clippy. Then we had Google Drive, we had Box, Quip, and so on. So I feel like the market for workplace productivity tools is big enough for multiple competitors to coexist.
That's all the time we have. Thank you.
Thanks, Ezgi.
The
pitch portion of this evening's MIT 100K launch competition. Before turning to the deliberation stage, I want to personally congratulate each of this year's finalists. It takes an unimaginable level of creativity, discipline, and conviction to make it to the stage today, and all of you have shown the best of what it means to be part of the MIT entrepreneurial ecosystem. And now, we will move on to the Audience Choice Awards. And in order to vote, you must check the email that you used to register for the Eventbrite link. You will have just received a link where you can go into the website to vote for your favorite team or teams. You can select as many as you want. And they will receive the 10K Audience Choice Award. And so now, without much further ado, the judges will be moving to a private room to record their scores, deliberate, and also choose this year's winners. We will see them in just a bit. Thank you. Please follow me.
Well, while we would like, of course, to be in that room with the judge, listening to that discussion about who is going to win, we're going to stay here. We're going to take advantage of the votes for the Choice Award, and we're going to have the incredible opportunity to hear from our past year's 100K winner, Dr. Francesco Benedetti of Osmoses. Francesco is the co-founder and CEO of Osmoses. He earned his PhD in chemical engineering from the University of Bologna, Italy, and worked as postdoctoral associate at MIT. He received the 2019-2020 MIT Energy Fellowship, a 2021 Activate Fellowship, and was an NSF I-Corp's entrepreneurial lead. Osmoses won the MIT 100K launch competition last year in 2021. They also won the 2021 Cleantech Open Northeast Accelerator, the Carbon Sequestration Prize, and in November 2021 closed a $3 million pre-seed round of financing led by The Engine and joined by other top national venture capital firms. He's also co-founder of Fail, Inspiring Resilience, a platform where exceptional people share unfiltered stories to make setbacks less intimidating and boost creativity and risk-taking in a world that needs it now more than ever. Please join me welcoming Francesco Benedetti.
Hello, everyone. It's a great pleasure to be introduced by an Italian fellow, and I hope you're ready for the second boost of Italian accent now for the next 10-15 minutes. First of all, let me acknowledge it's really great to be here today, and it's an honor for me to take you through our story and a little bit of our journey and provide an update. But first, let me tell you, this room looks very, very different than the room where I pitched the MIT 100K launch competition last year. This was the room. And it was really a crazy day. We were with our team. This is how the co-founding team of Osmoses looks like. I was with Holden, Catherine, and Zach. We were not just not in the same room like all people here today. We were in 3 different states on that day, and we were pitching, we were answering questions. And it was tough. It was tough because there was really not a lot of room to bounce the energy of the audience like it is today for all of these amazing companies that are pitching. So, we were very nervous. We were exchanging texts all the time on WhatsApp. I think it went crazy. And as we were now, I want to take you exactly in this moment as the judges were deliberating and we were waiting. We didn't have food probably for the last few hours. It's a very stressful event. And what happens is that we went to grab some food and we were just waiting for the judges to come out and tell us what would be the result of the competition. And the first outcome was the second place. And it was not our name. And at that point, our hope was going very low. We were really, really hoping at least for that. And it was not us. So I think the only comfort we had is that at least we had some warm food in front of us that we were eating. But then we got, the first prize was announced. And when they say Osmoses, of course, for us, it was really incredible. And I think it was one of the first moments probably when we felt that actually we could get this started and we had a shot, we had a chance to make it happen. So who we are, Osmoses is a clean tech company and we are transforming the way molecular separations are performed. And this is one of the most subtle and invisible problems, but that plays a huge role in climate change. And this is because the chemical, petrochemical, energy industries are defined by the fact that there's no product that is already pure enough to deliver value, or there's always some contaminants that has to be captured or separated from it in order for processes to move forward. And the cost of unmixing molecules for this industry and for the environment is huge. We're talking about 15% of the world's energy that goes into these separations, and 16% of the world carbon emissions that depend on the fact that we still rely on century-old technologies, like those that you can see here on this slide. So we're really addressing this problem, which is eliminating the energy waste with efficient separation technology, and in particular membrane technologies, reducing production costs for our customers, and CO2 emissions for the environment. And these two pillars, they need to come together so that you could deliver a solution that has value for the market today. You cannot sell without sustainability and vice versa. So what is the problem we're trying to solve, and why is worth starting a company for it? Well, first of all, I need to address that we decided to pick our beachhead market in the gas separation space. And separating gas molecules by size is extremely hard. And we're using a membrane approach, which is basically just a fancier word to say it's a filter. And if we look at this slide, you start from the left, the size difference between molecules is fairly big. It's very easy to separate water for grounded coffee. But then the more you go to the left, the more things become challenging. And actually, when you hit the smallest molecules, which are gas molecules, that's really where there's an unmet need in the industry today. So we developed this platform of ladder polymers that when manufactured into membranes, they leave behind porosities that have a similar size to that of gas molecules. And because of that, we can leverage extremely high and delivers extremely high separation performance and separate these gases in a very effective way. We also recently published the results of this research, which is where everything started. It was research between MIT and Stanford. In Science, another company already mentioned today that this was such an achievement, and I definitely agree, which means that there's a company that is a startup company that is commercializing breakthrough science, which I think is one of the best way to tackle something as big as climate change. So we have developed a platform technology that can address a number of different energy solutions. And in particular, we can follow the energy market basically wherever it goes. It has already been said a lot today about the left bucket of applications that we have in mind is decarbonizing new and existing industries. And in particular, carbon capture at point source for heavy industries like glass, steel, or aluminum, for instance. But also renewable and traditional natural gas upgrading, where there's a lot of need for improving the sustainability of this energy source that is very much present in today's life. On the other hand, the second bucket is really related to enabling carbon-free energy solutions, and in particular, we're focusing on hydrogen, both on the production side and the distribution side, which really contributes to lowering the cost of this energy source to make it commercially viable and, in general, have a chance to replace other sources of energies out there. So, as already was mentioned, we raised a $3 million pre-seed round last October. We announced in November. And this means that really there was a lot of attention around our technology, and we are not the only one excited about this. And we are extremely proud of the fact that the Engine is our lead investor, and we have Fine Structure Ventures, which is the venture arm of Fidelity, Orbia Ventures, and Little Green Bamboo. They're also participated in this round together with other angel investors. So we really are incredibly happy about the syndicate that we brought together for this round. But what are we using these resources for? There's a few areas of focus that we've been working on recently. The first one has been team development, which is probably one of the most important when you're starting a company. So we're hiring talent, and actually we had our group growing from 4 co-founders now to 9 people, and you'll see a picture of that later on. But this is also a very critical stage for a company to build a healthy culture. And this is very important because the impact that each of us, each member of the company at this stage has on developing this culture is huge. And I think it's really the right moment to do this. And we're focusing a lot of our energies in making sure that the company welcomes everybody. It's a diverse and inclusive company where everybody feels they can speak up, they can share, not just when they achieve success, but also when they have problems. And this is really something that is very important for us. But also in building the team, we're building an extension of our team with mentors, advisors, and also the investors that are all together contributing to the success of what we're doing. We're also working a lot on product de-risking, and in particular, we're focusing on scale-up. So we're taking this technology from the lab to industry, and really this takes a lot of scale-up effort. And in some key metrics, we've already been able to achieve 10x or 50x increased since last summer, which is really impressive, and I'm glad about all the work that the technical team is doing to this regard. And also intellectual property. So we developed this research project at MIT Stanford. So we had to get an option and license the IP from schools, which is also something that is a great experience. And at the same time, we are developing also IP on our own. Customers is also a key area of focus for us. We are going deeper and deeper into value creation and assessing where we can generate more value. Remember, we have a platform technology, so there's not just one solution that we can go after. And we're trying to understand what are the best pilot opportunities by assessing different scenarios. And we have a whole team that is looking into this today. So this is our team back in November when we announced the round. And as I mentioned, we're growing. This is our team today, actually as of April 4th. And this is at our lab space and office at the Engine in Massachusetts Avenue, here in the heart of Cambridge and the innovation. And below is the first launch that we had all together as a company. And actually, now that I notice that, I think it's pretty obvious that we're good at separations, because on one side of the table, there's all the people with long hair. On the other side, all the people with short hair. So it's clear that we're very good at separating stuff from one another, including people. There's a lot of things that happen, and I wanted to keep it light and have some pictures that kind of back up. So not for every news there's a picture, but we pitched at the Engine, which is when we got our funding since the MIT 100K. We really started establishing our lab space and facility, and that was the first picture when we brought our first big equipment that the MIT 100K helped buying, by the way. So a big round of applause for the MIT 100K that helps companies starting up. MIT Energy Night 2021, we were there. We also did a lot of moving. When you see a pitch, and the business models, etc., that is great, but then a startup company is also a lot of moving like that. You need to do a lot of stuff that are not, the fanciest things, but still very important to build a team, and kind of make you feel we're doing great stuff, concrete stuff. And we pitched a lot. We could probably present every week somewhere, but especially like Greentown Labs has been a great community also for us. We presented there a few times. We also were at CERAWeek. CERAWeek is the flagship event for energy. And we've been highlighted as one of the 5 companies in the sustainability by S&P Global that presented there this year, and we were there through invitation. So it was really a great experience, and we are moving forward with meaningful partnership also that we've been developing at these events. So just to recap, a little bit of progress and roadmap so far. We really started with this venture from a research project in the lab in 2017. It took us a couple of years to de-risk the technology enough to think we were ready to pitch it out there. And then we patented the technology, we validated that through a lot of customer discovery. We had a great, great fortune and great success to engage with a lot of programs here around the Boston area. We raised a $3 million round, as I mentioned, and now we're focusing on these pieces that on top of hiring, we're building industrial prototype modules, and we're going to sign JDAs, MOUs with customers soon. Before we raise the next round, which is going to be a seed round. And although companies are basically always fundraising, we've been talking with more than 100 firms out there in terms of investment so far. It's a great market, and we're gonna start officially this around the end of the year, early next year, and eventually we want to deploy this solution to customer pilots as soon as possible, hopefully ready by the end of next year. And, but as you can see, this, of course, looks like a very straightforward path. I would say I want to take a second just to acknowledge that it's not always everything great, not always works at the first time you try. And I think we've been through a lot of challenges that as a team, with a very strong co-founding team, we've been able to address. And I wanted to just acknowledge one because we are here at the MIT 100K this year. So we started applying for the MIT 100K last year with the pitch competition, like probably most companies that were already presenting here tonight do. And we applied, we worked so hard on that pitch. It took really several days to optimize that, to get to 90 seconds. And we didn't even pass the first selection stage. We received this very nice email, which was, unfortunately, your pitch was not selected to continue to the finals. And there was this very nice ad that was that we will encourage you to continue your entrepreneurship journey. And we took it very seriously. On the same day, however, we got this amazing email from Stuart, who said, it was a judge for that pitch competition. And he said that he was very excited about our innovation, and this is one of the things that really gets him excited. So on the bad news, there was also some good news. Somebody actually cared, and that really gave us a lot of energy to keep working on this. We went to apply to Accelerate. You can guess it. Also, we didn't get through this one. Actually, we got to the final 10, but then we didn't win anything. And you know what happened with the MIT 100K launch eventually, so we're very happy to celebrate that. And I want to take a second to acknowledge that this happened through support of really a lot of organizations and a lot of people. We started, in 2019, engaging with things like the MIT Deshpande Center for Technological Innovation, the Sandbox program, and MIT I-Corp, which is great, and NSF, also the national one. We went through a lot of accelerators and incubators like Climate Tech and Energy Prize, MIT 100K, the Engine Blueprint program, and the Clean Tech Accelerator. We became Activate Fellows. We are part of Greentown Lab. So really, we did everything we could to learn a little bit more step by step how to make this happen. And all of these people and more really helped us, going from where we were to where we are, and hopefully keep growing in the future as well. So something I wanted to acknowledge, we never got a chance to take our picture with the big check. We got the small check, which was still $100,000 to acknowledge MIT 100K, but we took this picture to, in perspective, this looks a big check as well, so I think it was great to show, but also the organizers were super kind, and last November when we had the first in-person pitch, they invited us and we took our picture with this amazing sign, and I wish all my co-founders were here today to do the same again. And I want to close by closing like what I did like 1 year ago when I was back home giving the pitch, and I think I said, the time is now, we're ready to meet the challenge. Thank you so much for listening. And good luck to all of the companies. Tonight is the beginning of a great journey, and I'm just at the beginning too, but it's something that I wanted to say.
They have to begin from somewhere, right?
Yeah.
Thank you, Francesco. It's amazing to see how far you've come since last year when you won the 100K. Before you go, I have a question for you. You also are the founder of FAIL, Inspired Resilience, and I think it's something that is very important for those who start the entrepreneurial path. Just like a few more words about FAIL and what you do?
Yes, so I think FAIL has been very instrumental for me to think more and more about what it means to build the culture of a company. And I think I realized by being, at MIT in very hyper-competitive environments, and it's definitely common throughout all around the world, there's a lot of challenges with expectations, with the fact that people feel like they need to be perfect to achieve anything in life. And we're always exposed to just the things that actually work without ever really going into the details of when things didn't work, failures, setbacks, etc. And I think that helps normalizing the idea that sharing those events as well helps normalizing the idea that you don't need to be perfect to become that role model that you're dreaming to be. And by having people that achieve amazing things in life, sharing some of the aspects of when things didn't work can help others take more risk, be more creative, and really do things that require courage, which is what everybody needs today in this society when there's so much that we need to improve and work on. So I hope that's going to contribute to something as well.
Thank you. Thank you, Francesco. Please join me again. Thank you, Francesco from Osmoses.
And the wait is finally over. The judges wanted to let you know that this was an especially difficult judging round. Yeah, I'm sure that's not easy to hear, but it was an especially difficult judging round. So first, I'm going to start with the third place.
Congratulations. So, Ezgi, I think. The third place is going to be...
do we want to first remind
can we
the category
bring this?
are?
Yes, please.
Sorry, guys.
Okay. All right. So the third
We
place
wanted to bring out the check first.
is RT Microfluidics. Congratulations. Congrats.
You can move over that way. All right, and the second place award goes to Inclusively. Oh, there she is.
And now, thank you to your online votes. We have also determined the winner for the Audience Choice Award. That was basically the team who got the most of the vote among the audience that is present here tonight at the event. And the Audience Choice Award of $10,000 goes to...
Sparkle.
Congratulations.
Thank you.
Congrats. And without further ado, for the final and largest prize of the night, which is named for Robert P. Goldberg. Robert graduated from MIT in 1965 and received a PhD from Harvard in 1973. Robert and his wife Judy married in 1969. Robert loved MIT, and entrepreneurship was in his DNA. After founding and taking BGS Systems public, Robert returned to MIT as a visiting scholar at the Sloan School. Here he developed a course in entrepreneurship and mentored MIT students for what was then the MIT 10K competition. Robert was exceedingly generous in the community, and that generosity has been mirrored by his family. His children and wife Judy felt that funding the 100K competition was an appropriate and worthwhile memorial to his entrepreneurial spirit. We're proud to honor his memory with this award. And drum roll, please. And the 100K award goes to Nona Desalination.
Take a picture with them. Thank you to all the teams that competed here tonight. Thank you to our judges. And thank you so much to you, the audience, for being with us today to celebrate entrepreneurship and creativity around this campus, around MIT. We are so grateful that you were able to join us today, and we're really looking forward seeing you the next semester at pitch competition. Thank you, everyone.
Thank you.
Thank you.
That's it.